This is section 5.3 on solving trig equations. So now we are going to be using what we did in the last two chapters to actually solve an equation for x if it involves a trig function. So what is a trig equation? So a trig equation is an equation where the variable occurs inside of a trig function. So for example, if we have the sine of x plus 1 equals 2, that would be an example of a trig equation because the x is grouped together with our trig function. So to solve a trig equation, we have a couple of steps we're going to follow. The first step is use inverse algebraic properties to get the trig function alone on one side of the equal sign. So this is kind of like what we would do if you were solving a regular equation where we get x alone on one side. The second step is use the unit circle to find the angle or angles that make the statement true. So that is why I have this unit circle here. We are going to be using the unit circle to help us solve these. So once you have your trig equation alone on one side of the equal sign, you go to the unit circle, and then our last and final step is if in the question it asks for you to write it as a general solution, you put at the end plus 2n pi. So this plus 2n pi means, for example, if our solution was 1, so plus 2n pi means that if we circle around one time, so n would be 1 plus 2 pi, we come back to 1. If I circle around another time, so n would now be 2, so that would be circling around 4 times, I still come back to this same point. So that's what a general solution means. It means not just the numbers on the unit circle, not just from 0 to 2 pi, but from 0 to infinity. So here we have some examples. It says find a solution on the interval 0 to 2 pi. So since it does not ask for a general solution, it doesn't state that. It says on this interval, we would want to, we don't have to add this in. Let's say you get a question where it doesn't say, it just says find the solution, then you would want to add plus 2n pi. So because it says on the interval 0 to 2 pi, we do not have to do step number 3. So solve the following equations for x. Write your answer as a solution from 0 to 2 pi. So here we have 6 sine x plus 3 equals 4 sine x plus 2. So when you have a trig function on both sides of your equation, you want to move one over to combine with the other side. So it's kind of like you can have two x's, but you want to all move them all over to one side, and then all of the other numbers go to the other. So for this equation, we are going to start by moving 4 sine x, subtracting it over to the other side. So if I subtract 4 sine x from both sides, on the left, I'm left with 2 sine x, because 6 minus 4 is 2, plus 3 equals 2. So now I want to get this alone on one side. I want to get my trig function alone. So first we're going to subtract the 3, and then we're going to have to divide by 2. So minus 3. So when we do that, we're left 2 sine x equals negative 1. And our last step is to divide by 2. So sine of x equals negative 1/2. So once you get to this point, this is where you then go to the unit circle. So if you think about sine on the unit circle, sine goes with y. So we're looking for a y value that is negative 1/2. And whatever that angle measure is, that will be our x value. So your x values always are your angle measures, and the number on the alone in the equation is what you look for in the point. So x is always an angle. The number that's alone is always somewhere in the point. Because this is sine, this is saying we want -1/2 to be the y value. So if we go up to our circle and we look in all the y values, I see here is a -1/2. So that would be 7 pi over 6. And here's another -1/2 as a y value, which is 11 pi over 6. So those are my two y values, 7 pi over 6 and 11 pi over 6. So that is what my x equals to. Now let's say it asks for the general solution, you would add plus 2 and pi to each of these, but it doesn't. So we just leave it like that, and that is our final answer. So you are not plugging these into the calculator. Just want to make that clear. So let's try this next example. It says cosine of x plus 1 equals 0. So our first step, we want to get cosine of x alone. So in this case, to do that, we are going to subtract 1 from both sides. We get cosine of x equals -1. So now we have cosine of x alone on one side. Cosine goes with x. So we're looking for an x that is -1. So now we go to the unit circle. We're looking for an x that is -1. So here I see 1. So we have -1, 0, and that would mean my angle is pi. Let me erase these. And that looks like the only one. So for this one, we just have one answer, and the answer is x equals pi. So your final answer should always be an angle measure in radians. Our last one, we have the square root of 2 times sine x plus 1 equals 0. So we want to get sine x alone. So to get sine x alone, we have to subtract 1 from both sides. That's -1, and then we're going to divide by the square root of 2. And then what happens here is we get -1 over the square root of 2. So that is not, we need to simplify that, get the radical out of the denominator. So when we multiply by root 2 over root 2, we get negative square root of 2 over 2. All right, so for this one, when we got sine x alone, subtracted the 1, divided by root 2, then we had to simplify by multiplying by root 2 over root 2, and we get negative square root of 2 over 2 is what sine x equals to. So sine is y, so we're looking for a y that is negative square root of 2 over 2. So now we have to go up to our unit circle. We are looking for a y value that is negative square root of 2 over 2. So here's one. There is my angle measure, and here's the other one. There's my angle measure. So we have 5 pi over 4 and 7 pi over 4. And those would be my two answers. So x equals 5 pi over 4 and 7 pi over 4. So for part 2, it says, solve the following equations for x, write your answer as a general solution. So now we have to do that third step up here where it says if the question asks for general solution, add plus 2 and pi. So now we have kind of a different looking equation. We have a square in here. So anytime we have a square, cosine square, we want to factor. So to factor this, they both have a cosine x. So that would be our GCF. And if we take one cosine out of here, there's one left. And if we take one out from here, there are none. So we write 1. So now we have two factors. We have cosine x and cosine x plus 1. So anytime you factor, you set all of your factors equal to 0, and you solve them each separately. So this one, we already have cosine x alone on one side. This one, we need to add 1 to both sides to get cosine x alone. So now we can do exactly what we did at the top. Cosine is x, so we're looking for an x that's 0, and then we're also looking for an x that is positive 1. So we go to our unit circle. So looking for an x that's 0 and positive 1. So here's one that's positive 1. And let's look for 0. Here's one that's 0. And here's one that's 0. All right, so we have positive 1, so we'll put 0 pi, pi over 2, and 3 pi over 2. So when we write our answer, we write it together. We don't have to write separate. So we had 0, we had pi over 2, and we had 3 pi over 2. So each of these we're going to add plus 2n pi, plus 2n pi, plus 2n pi. And that's saying if I take another lap around, I get back to the same point. So for pi over 2, if I take a lap around, I get back to that same point. If I take another lap, I get back to that same point. And so the n just stands for the number of times you're circling around. And that is what we call a general solution. So now for number 2, now we have cosecant. So we're going to see how that one plays out. So for this one, we have a square. So we can either think about factoring, or we can think, if we're not sure if we can factor this, we might have to solve it by square roots. So in this case, because there's only one trig function, we can solve by using square roots. And I'm going to show you how that works. So first, we're going to start by adding 4. We want to get cosecant squared x alone on one side. Divide by 3. So we're left with cosecant squared x is 4/3. So now what we can do is get rid of this square root, this square, by square rooting both sides. So when I square root both sides, keep in mind you always end up with plus and minus. The square root of 4 is 2, and the square root of 3 is not a perfect square, so I'm left with the square root of 3. So the cosecant of x equals positive and negative 2 over root 3. So now this is where we want to flip our fraction. So cosecant of x is equal to 1 over sine x. So what we can do is we can write this equation, the sine of x is equal to positive and negative, and we flip. So sine of x is equal to plus and minus square root of 3 over 2. So here we are looking for a y value that is positive or negative square root of 3 over 2. All right, positive or negative square root of 3 over 2, and we're looking for sine. So here's a positive. So we have pi over 3. Here's 1, 2 pi over 3. Oop. And then we have 4 pi over 3 and 5 pi over 3. So your answer should match up with the angles being very similar. So it's all the pi over 3. So our final step would be to write x equals pi over 3 plus 2n pi, 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. So the last example is secant squared x minus 4 equals 0. Here we can break this up. We can do this two ways. So the first way is we can factor it. So because this is a difference of two squares, I get secant x plus 2 and secant x minus 2. And you set both equal to 0 separately and solve. So for this one, we subtract 2. So we get secant of x equals negative 2. So when we add it, secant of x equals positive 2. Or you could also solve this one like we solved the one previous and take square roots if you wanted to. So here, now we need to flip. So secant is the reciprocal of cosine. So this is really saying the cosine of x equals negative 1/2, and the cosine of x equals positive 1/2. And cosine goes with x. So we're looking for an x that's negative 1/2 and an x that's positive 1/2. Going up to the unit circle. So here is positive 1/2, pi over 3. Here's a negative 1/2, 2 pi over 3. So once again, it's the pi over 3's. 4 pi over 3 and 5 pi over 3. So our answer is actually exactly the same as our previous question. We would write x equals pi over 3 plus 2n pi, 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. So you can check out the try examples, and that is it for this section.